So the next set of functions that we are going to study are identity function and modulus function. So you have identity function. We've already seen what an identity relation is. We have the same definition here. So identity function is a function which is defined as f of x is equal to x or y is equal to x. That is, whatever number goes in, the same number comes out. So if 1 goes in, 1 comes out. If 2 goes in, 2 comes out. If 3 goes in, 3 comes out. If 2.5 goes in, if 2.5 comes out. So whatever value goes in, the same value comes out. That's called an identity function. Every element is mapped to itself. That's called identity function. So what is the domain of this function? The domain is all real numbers, because any real number can go in, because it is giving the same value outside. And what is the range of this function? Any real number, because whatever is going in is coming out. So both the domain and range of this function is real numbers. And what is the graph of this function? So if you want to draw the graph, you have already seen how to draw the graph. You take some sample points. So x, y. So if x is equal to 0, y is equal to 0. If x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to 2, so on. So if you plot the points and join them by a smooth curve, you get a straight line, which is exactly in between x-axis and y-axis. It makes an angle of 45 degrees with x-axis. So there's nothing new about identity function. You know this function already in your lower classes. Now let us go to our next function. So the next function is the modulus function. It's a very simple function, and I feel this is the most important function that you need to master. So this modulus function has applications in most of the other chapters. So what is the modulus function? This is represented as f of x is equal to mod x. And the definition of mod x is equal to x if x is greater than or equal to 0 minus x if x is less than 0. A very simple definition. It's a piecewise definition. When x is greater than or equal to 0, you have a definition. When x is less than 0, you have a different definition. For example, modulus of 2 is nothing but. So what is mod of 2? So you just need to see whether this 2 is positive or negative. We know that 2 is positive, right? 2 is positive. So you just get x as the answer. That is, the answer is 2. What is modulus of minus 2? So you can see that minus 2 is a negative number. X in this case is less than 0. So the functional value mod of x is equal to minus of whatever is there inside mod. So minus of minus 2 is nothing but plus 2 again. So in a way, mod does not do anything with positive numbers. Whatever positive number goes in, it just gives out the value. And if a negative number goes in, it converts the number into a positive number and gives it out. And how does it convert a negative number into a positive number? It does not take away the minus sign. So if I ask the machine to take away the minus sign, that's not what mod does. So mod adds another minus to the minus already there. So minus into minus becomes plus by mathematical properties. So if you take the machine interpretation of this mod function, so if an x goes in stage 1, it checks whether the number is positive or negative. So assume that the positive numbers goes here, negative numbers goes here. So the first check is the number is positive or negative. So if the number is positive, the number directly comes out. If the number is negative, the modulus function adds one more negative to it. So negative of negative becomes positive and comes out. So that's what mod does. If I ask you mod of minus 256 is nothing but plus 256. But how is it becoming plus? It's nothing minus of minus 256. That is equal to plus 256. So I'm stressing this point because this is the point that you need to understand. So if a negative number is there inside mod, you just need to understand that mod makes it positive. But that understanding is not sufficient. You need to understand how a mod function makes a negative number as positive number. So it adds one more minus to this number. So minus of minus 256 becomes plus 256. So I hope you have understood the definition of this function. Now what is the domain of this function? The domain is nothing but real numbers because this machine does not have any problem with any real number. So positive real numbers can go inside or negative real numbers can go inside. What is the range of this function? The range is close at 0 to infinity because if I send positive numbers inside this machine, positive numbers comes out. If I send 0, 0 comes out. But if I send negative numbers also, only positive numbers come out. So negative numbers cannot come out of this machine. Hence the range is close 0, infinity. And how does the graph of this look like? So when x is positive, the graph is nothing but y is equal to x. So if I take this as y, so when x is positive, y is equal to x. It is 0, 0, 1, 1, 2, 2, 3, 3, so on. It joins all these points. So I get a straight line like this. So when x is positive, you get a straight line like this. When x is negative, you have minus 1, minus 2, minus 3, so on. If x is negative, you can very clearly see that. For x is equal to minus 1, y value is minus of minus 1, which is plus 1. So this point will be there. So for x is equal to minus 2, mod of minus 2 is plus 2. For minus 3, mod of minus 3 is plus 3. So you have a function like this. So if you take y is equal to mod x, the graph looks like a V. So mod function's graph looks like a V. So now let us look at some of the important properties of modulus function. The first property is square root of x square is equal to mod x. So in the lower classes, what you have done is if you have square root of some number square, you have cancelled out square root and square and you have written this as x. But in 11th class, this process is dropped. So whenever you have square root of x square, the answer will be mod x. That is, if you have, for example, if you have square root of 1 minus x whole square. So square root of 1 minus x whole square, you cannot write it directly as 1 minus x. So square root of 1 minus x whole square cannot be written as 1 minus x because we don't know whether 1 minus x is positive or negative. Square root of minus 3 whole square. So this square root and square cannot be cancelled because this is a symbol for positive square root. So positive square root of minus 3 whole square is nothing but square root of minus 3 whole square is 9. What is square root of positive square root of 9? It's plus 3. So square root of minus 3 whole square, the square root and square does not cancel each other. To get minus 3, the answer is plus 3. So square root of minus 5 whole square is mod of minus 5, which is equal to 5. Mod of minus 5, which is equal to 5. So square root of 1 minus x whole square is not always equal to 1 minus x. Because we don't know whether 1 minus x is positive or negative. So what we know is we get the positive value of this number as the answer. So square root of 1 minus x whole square, you should write it as mod of 1 minus x. So mod of 1 minus x is equal to exactly 1 minus x if 1 minus x is greater than or equal to 0, minus of 1 minus x if 1 minus x is less than 0. So 1 minus x is positive implies x less than or equal to 1. So if x is less than or equal to 1, root of 1 minus x whole square will be exactly equal to 1 minus x. If x is greater than 1, that is if x is something like 5. So square root of 1 minus 5 whole square is not 1 minus 5. If you write it as 1 minus 5, you get the number as negative. So square root of 1 minus x whole square is equal to minus of 1 minus x. You know that if the expression inside mod is negative, you add one more negative. So that is equal to x minus 1. Minus of 1 minus x is x minus 1 if x is greater than 1. So 1 minus x if x is less than or equal to 1, x minus 1 if x is greater than 1. So you can see why this is happening, because root of 1 minus x whole square can be written as root of x minus 1 whole square also. Both are same, right? Because even if you take a minus common from this, minus 1 whole square will become plus 1. So root of 1 minus x whole square is same as root of x minus 1 whole square. So if I directly cancel this out, so you get the answer as 1 minus x from this, you get the answer as x minus 1 from this. So you have to decide which is right. So both are right in their specific intervals. So now let us go for the second property.